how extinct animals could be brought back from the dead using the genome editing technique that won the Nobel Prize, CRISPR-Cas9. Extinct animals like the Tasmanian tigers could be brought back from the dead, according to scientists. Thylacines, sometimes referred to as Tasmanian tigers, roamed Australia millions of years ago, and these dog-like striped creatures, which were about the size of an American coyote, vanished from the mainland about 2,000 years ago. They stayed in Tasmania until the 1920s, when European colonists who perceived them as a threat to livestock killed them off. It was a human-driven extinction. European settlers came to Australia and brutally obliterated these animals, says Andrew Pask, geneticist at the University of Melbourne. Scientists under the direction of Pask are working with Colossal Biosciences, a company dedicated to de-extinction, to resurrect the wolf-like creature. The thylacine is not the only extinct animal that may soon be seen again, thanks to genetic discoveries in recent years, including the development of the genome editing tool CRISPR-Cas9. What types of moral issues are raised by de-extinction science, and how does it operate? Sequencing the DNA of an extinct animal, which is the genetic code found in every single cell of the body, is the first stage in the study of thylacine. In 2017, Pask carried this out. He said, "The great thing about the thylacine is that it is as much such an important marsupial every major museum wanted one in their collection. So there are hundreds of samples around the globe, and some are exceptionally preserved," he said. And here, of course, we have a picture of them before they got extinct. Now, the well-preserved examples of thylacine have allowed the animal's DNA to be sequenced. He said, "Our sample was a baby taken from its mother's pouch. They shot the mum and immediately dropped the baby into alcohol, which preserves the DNA. That was a miracle specimen that the Holy Grail for us in terms of being able to really build that genome," he said. "The DNA is not quite full, but it's in pretty excellent shape. DNA breaks down into brief fragments throughout time as a result of bacterial action, UV light exposure, and other factors. There is no hope of bringing back a dinosaur, since the fragments that are left behind get smaller as the sample ages and eventually run out. Scientists are now faced with the seemingly insurmountable task of figuring out how the many pieces of DNA fit together. This is analogous to trying to do a large jigsaw puzzle without the aid of the picture on the box's front. Fortunately, a Denard, a marsupial about the size of a mouse, was able to offer a blueprint. Pask said, "We found the closest living relative to the thylacine, which was the Denard. It's estimated that 95% of the DNA between Denards and thylacines is highly conserved, meaning it has not changed significantly through time. Nobody's done this on this scale before because the DNA editing technique was not good enough or quick enough," Andrew Pask said. He said, "We sequenced the Denard's genome and compared that genetic code to our extinct species. When then we overlapped them and found everything where it was different." And he said, however, only knowing an animal's DNA will not be sufficient to resurrect it. The next step in the challenge is to change Denard's genes to match those of the thylacine, the Tasmanian tiger. The genome editing technique that won the Nobel Prize, CRISPR-Cas9, can be used for this, he said. And he said, "We start with living cells for the Denard, and we begin to edit all of those changes, so we essentially engineer or turn that Denard cell into a living thylacine cell with thylacine chromosomes in it. The many sequences of the thylacine DNA could not previously be changed all at once due to the limitations of earlier gene editing technologies. It was anticipated that due to the millions of modifications required, the most crucial DNA sequences would need to be prioritized, producing an animal genome that wasn't exactly the same as the extinct one. Pask believes this will no longer be necessary. All of those technologies are in place, but nobody's done it on this scale before because the DNA editing technology was not good enough or quick enough. But now it's come such a long way that we do not have that tech, and we do have that technology, and we have had significant investment to try and make this work. Once the scientists have a thylacine cell, they say they still need to develop it into an embryo, then implant it into the womb of a living relative. If that sounds simple, it probably is not. Pask says we have a lot of work to do. We've already made marsupial stem cells, which took us about 5 years. We're now putting those stem cells into embryos to see if we can get them to develop into a whole living animal. Are we playing God? There are ethical issues even if we can revive extinct species. Mammoth and thylacine reintroduction could disturb current ecosystems. Other species will have evolved and adapted to take their place since these animals went extinct, and this will have an impact on their organisms. The ecosystems that these creatures once called home may have undergone significant change as a result of climate change. A few of the vegetation that woolly mammoths consumed are also extinct. If not, who would take care of mammoths if they couldn't thrive in the wild on their own? Would they merely become exhibits at the zoo? Pask says, I don't think we should bring all animals back. I think it should have to fit certain criteria. For the thylacine, the Tasmanian tiger, it's a recent extinction event, so its habitat in Tasmania still exists. All the food it used to eat still exists, so there's somewhere for them to go and they can thrive again in that environment, he said. This animal also played a critical role in the ecosystem. It was an apex predator, so it sat right at the top of the food chain. There are no other marsupial apex predators, so when it was made extinct, it left a massive gap. Some scientists contend that attempts to resurrect extinct species could interfere with conservation efforts to save current animals that even raise the possibility of biodiversity loss. They also claim that people may be less motivated to give up eating meat and destroying habitats if these efforts are made. De-extinction technology, however, could be employed to save live species that are in danger of going extinct, particularly those with a very small gene pool, such as the white rhino. I think the ethical issue here was the impropriety of humans making these animals extinct in the first place, said Michael Archer. Every ferret alive today can trace its ancestry to only 7 people, making black-headed ferrets one of North America's most endangered species. But recently, scientists at Chile's Santiago Zoo used frozen cells from a black-footed ferret that had passed away 30 years ago to clone Elizabeth Ann. Elizabeth can contribute a welcome boost in genetic variety to the population because her DNA is completely unique. De-extinction technology is not just about bringing back the thylacine, it's about preventing other animals from becoming extinct, Park says. He says we have so many bushfires in Australia, and with rising global temperatures, we're going to see more diverse weather events in the decades to come. What Australia has been doing is collecting tissues from marsupials in those areas that are most at risk and freezing them. This means that if a bushfire came along, once the vegetation grew back, you could repopulate the area with that species. Archer agrees that the moral rights outweigh any wrongs. He says, I think it would be unethical not to do it. I think the ethical issue here was the impropriety of humans making these animals extinct in the first place. It's not about playing God, it's about playing smart human by undoing what we did, he said. And this is on Great Game India. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box.